All right, let's talk about something that feels like ancient history now, but was actually a huge deal. We're going way back to the late 90s to figure out how in the world we got the internet, the whole thing, onto our phones for the very first time.
I mean, seriously, look at this phone. It's wild to even think about, right? Before we had apps, before we had iPhones, engineers were staring at this massive puzzle. How do you take the big, beautiful, sprawling desktop internet and cram it onto a tiny screen with a connection that was, let's be honest, painfully slow? That's the puzzle we're going to solve today.
So, to really get the solution, we've got to wrap our heads around the problem first. And back in the late 90s, it was like we were living in two completely separate tech universes, each playing by its own rules. On one side, you had the desktop world. We're talking big monitors, pretty fast internet connections for the time, and computers with decent processing power. They spoke the language of the web, HTML. But then you had the mobile world. Tiny little screens, super slow connections, and barely any battery power. Trying to load a normal website on one of these phones, it was like trying to force an elephant into a shoebox. It just wasn't going to happen. The tech just wasn't built for it. So you can't use the old plan. You need a new one. A completely new set of rules, a new language, really. One that was built from the ground up just for these little pocket-sized devices. And that is exactly what they did. The big answer was WAP, which stands for Wireless Application Protocol. You gotta remember, back in 1997, the giants of the phone world, Nokia, Motorola, Ericsson, they all got together and said, we need to fix this. So they created this new standard. You can think of WAP as a super smart translator and a super efficient delivery service all rolled into one. Its whole job was to make internet stuff light enough to travel over those slow wireless networks and simple enough to actually show up on a tiny screen. And WAP wasn't just one single thing. It was a whole stack of technologies. Kind of like a layer cake. Now, you don't need to memorize all these acronyms, that's not the point. The key thing to get is that each layer had a very specific job. One layer was just focused on managing the spotty connection. Another one was just for security. Another one made sure all the pieces of data actually showed up. Altogether, this whole stack made the system incredibly efficient, which was absolutely critical for these slow, unreliable networks. Okay, so if WAP was the fancy delivery system, what was it actually delivering? Well, the content itself was written in a language called WML, or Wireless Markup Language. This was basically the mobile world's version of HTML. It was super stripped down, ultra simple, and designed to do one thing and one thing only: get basic text and links on a phone screen without wasting a single bit of data. And this is where the thinking was just brilliant. A normal HTML web page is one long scrolling document, right? But a WML file was thought of as a deck of cards. Each card was just one screen's worth of information. So when you clicked a link, your phone would download the whole tiny deck at once. Then you just use your phone's arrow keys to flip between the cards, see? This meant you didn't have to keep going back to that slow network for more data. It was so clever. And if you look at the code itself, don't worry, it's actually way simpler than it looks. That first tag, WML, that just says, hey, this is a deck. Inside that, you have a card tag. That's one screen. And that little P tag, that's just the paragraph of text you'd actually read on your phone. That's literally it. A tiny, efficient little package built for a tiny device. Now, hold on. While the mobile world was getting really good at this minimalist, text-based card trick, something totally different was bubbling up on the desktop. The web wasn't just getting prettier, it was starting to feel alive. First up was CSS, or Cascading Style Sheets, and this was a revolution. It let web developers separate the stuff on the page, the words and pictures in the HTML, from the style of the page, the colors, the fonts, the layout. Suddenly, designing big websites got way easier and looked way better. And then things got really interesting with something called DHTML, or Dynamic HTML. Now, this wasn't a totally new language. It was more like a powerful recipe. You take your HTML for the structure, you add your CSS for the style, and then you sprinkle in a scripting language like JavaScript to add behavior. For the first time, web pages could actually react to what you were doing right away without having to reload the whole page. DHTML completely changed the game for desktop users. All of a sudden, websites had drop-down menus that worked. Little animations, interactive forms. They started to feel more like software programs than just static pages. And this really drives home the point. The gap between the two worlds was getting wider and wider. While WAP was laser-focused on just delivering the absolute basics, the desktop web was exploding into this rich, dynamic, interactive experience.
So you've got these two completely different universes, right? The super simple mobile web and the flashy, dynamic desktop web. But here's the thing. Underneath it all, they were both powered by the exact same fundamental engine of the internet.
And that engine is the client-server model. It's really the heartbeat of the internet. On one end, you have clients. That's your web browser on a computer, or the little micro browser on your WAP phone. They're the ones requesting information. And on the other end, you have servers. These are the powerful computers that store all that information and serve it up when asked. Every single time you go online, you're part of this dance. So how did this actually work on a WAP phone? Well, this is where the magic happens. The secret ingredient was a middleman called a WAP gateway. So you click a link on your phone sends this tiny compressed request to the gateway. The gateway then translates that tiny request into a normal internet request that a web server can actually understand. Then, when the web server sends the page back, the gateway works its magic again. It takes that page, squishes it down, and converts it into that super compact WML format your phone needs. That gateway was the essential bridge connecting the two internets. Without it, none of this would have worked.
So let's be real. Looking back now, WAP and WML seem incredibly primitive. They were slow, they were clunky, they were really limited. But their importance is just impossible to overstate.
See, WAP and WM were never meant to be the final destination. They were a bridge. They solved a very specific, very critical problem at a very specific time. And what they did, most importantly, was prove that a massive demand for internet on the go actually existed. They created the very idea of a mobile web, and in doing so, they paved the road for the faster networks, the powerful smartphones, and the amazing mobile web we all just take for granted today. And that really leaves us with one last thought. WAP was this imperfect but totally necessary piece of technology. So it makes you wonder, what are the imperfect, maybe even kind of clunky technologies that we're all using right now that are actually the quiet, essential stepping stones to whatever the web is going to become tomorrow? Thanks for joining us on The Explainer.